We're live. Okay. Awesome. Hold on. Where can we go change? Hmm. Well, it's okay. Let's begin. Hold on. Well, first, I'm just going to go to the bathroom to make sure that we don't have to go later. Let's do this. Let's do this. So, I'm going to share my screen. Our entire screen. Yes. Cool. Let's go. So let's see. So we're in problem 2. I'm sorry. I know I begun without you guys, but it's okay because we still have like 10 problems left. Um, and in fact, we can probably use our whiteboard here. Um, what is it called? Canva whiteboard. Oh, cool. Here we are. Beautiful. Beautiful. Let's go. So, while you guys were gone, we finished all of module 4 in the quiz, and then we finished exam 2. Then we finished module 5, which we covered applications of derivatives, mean value theorem, all of that. And then we did a mastery of differentiation exam, and now we're in optimization. And then after this, we only have to finish 6.2, the quiz. Then we got to finish the exam. Then we have integration, then the final exam, and then we're done. So, uh, my plan, I mean, I should finish before like around April 24th. So I have around left, not even 2 weeks. So we gotta hurry up. But we're doing good. We have good momentum right now. We have good momentum. So I think I'll just split the screen because why not? Um, let's see. We'll have that, and then we'll have that. So over here, cool. And y'all can see me well, right? Okay. Let's begin. So, suppose that f of x equals 8x minus 5 ln of x, and that x is greater than 0. Okay, so yeah, so f of x equals 8x minus 5 ln of x, where x is greater than 0. But before we begin, I have one question. I have my camera right there, but why isn't it showing it like this? It's kind of weird. Oh wait, hold on. What if I go here? Da 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 da. It's the most wonderful time of change camera. What happens if I do that? Oh, gotcha. That's why I can't do it. Can I change the camera here? Whoops. Probably not. But no, we got to focus. So we got to list all critical numbers of f. Gotcha. Critical numbers. So what I remember is that critical numbers are values of x that make f prime of x equal to 0. Yeah, or undefined, but that these values are defined for f. So here we have f prime of x. So first, let's solve for f prime of x. So here we got equals 8 minus 5 times 1 over x. Right? I'm not missing anything, right? Yeah, 8 minus 5x. Yeah, no chain rule involved, no quotient rule or anything. Yeah, no. We're good. All right, and then we know that the critical numbers equal here to 0. So all we got to do is just solve for x, because that's going to be the value that makes this equation equal to 0. Cool. Yeah, or undefined. Let's see. So what makes this undefined? Well, looks like 0 makes all of this undefined. And if we plug in 0 in f of x, what do we get? So so e to the power of what is 0? 1. So we have negative 5. That's defined. So I think 0 is going to be a critical number. Uh, and what makes this equation 0? Okay, so we have negative 5 over x equals, equals negative 8. We got 5 equals 8x. For real? I'm not doing anything wrong, right? And then we finally have x equals 8 over 5. Yeah, I don't think we can simplify anymore. Yeah, so that's what we have. So here is another critical number. Oh, and let's check if it's defined. 8 over 5. That's 1. Whatever. Yeah, it looks defined, right? I think I'm not missing anything. X equals 8 over 5. So that's another critical number. 8 over 5. Is there any other number that makes this? No, we're good. I think I'm not missing anything, right? If we get, oh, so that's wrong. Let's see. Oh boy, here we go again. Oh, and x is greater than 0. Okay, so that means we only have 8 over 5, I think. So is it just this? That's also wrong. Oh boy. Let's see. Yeah, so here we multiply by 5. We have negative 5 equals negative 8. And then we have x equals negative 5 over 8. Oh, whoops. Hold on. I'm not paying attention today. My bad. We have 5 over 8. Whoops. Hold on. And since x is greater than 0, so I think here we only have a 5 over 8. Gotcha. Yeah. And if we go here, oh wait, we have a video. Oh, awesome. Okay. Oh wait, that's analyzing the function. Whatever. All right. So let's see. So we have 5 over 8. So let's recap everything we did so far. So x is greater than 0. So therefore, even though 0 is a candidate for a critical number, it does not fit on the conditions that need to be met. Yeah, so we found the derivative, and then we found the value of x that made the equation go to 0. So we know that that's a critical number. All right, use interval notation to indicate where f of x is increasing. What does this x greater than 0 mean? Hold on. I mean, even though it's not a critical number, I wonder if we consider that when we make our intervals. Let's see. Yes. Okay. So we got that right. Okay. So that's what we need to consider. All right. So use interval notation to indicate where f of x is increasing. So right, since x is greater than 0, so we're not gonna check the interval where x is less than 0. So we're only gonna check from 5/8 all the way to infinity. That's what we're checking. Let's see. So picking a random. So what's 5/8? A 5/8 is less than 1, right? Less than 1. So if we pick, I don't know, something like 2, our candidate is 2. So we can check whether f of x is increasing by checking whether f prime of x is greater than 0. So f prime of 2, what is this going to equal? we get 8 minus 5 halves. And that's surely greater than 0, right? That's 11 halves. And yeah, that's obviously greater than 0. So yeah, thus f prime of x is increasing within this interval. So therefore, in the interval between 5/8 and infinity, f of x is increasing because if prime of x is greater than 0 within that interval. And decreasing, well, I think it's just going to be not including 0 all the way to 5/8, right? Yeah, if we press... All right, awesome. We're doing well. We're doing well. We're not understanding everything. There's some things that I would like to understand, but it just comes with practice. So, oh, hey. What's up, man? It's good to have you here. Thank you. Yeah, just join me and watch me do math. Or you do your math homework as well. Whatever you want, man. But right now, we're focused on finding the local maxima of f. Local. Local. That does not seem like global. It does not seem absolute. It only seems like a local. List the x coordinates of all local maxima of f. Oh boy, okay. Let's see. X values of local maxima. So here's what we're going to do. Local maxima happens when we have a positive slope, then a negative slope. So what does that mean? So therefore, in the critical point right here, we must have a positive, here. We must have like you must have an f prime of x that's greater than 0. And then here, it must change to f prime of x less than 0. I think, right? Negative, so positive. Yeah, right. So in our critical value, what was our critical value? We had 5/8. So we got to check whether on the left of this it was positive, and then as we passed 5/8, we got to a negative slope. All right, this notation is like super inaccurate, but I mean it helps me understand. So let's see. So on the left we had decreasing right here. Yeah. Oh wait, hold on. Well, this is so f prime of x here. I'm sorry. F of x is decreasing. So actually, we see something like this then, and that's not what we see here. So I don't think that there's a local maxima, but we do have a local minima at that critical point. Yeah, because here we're decreasing from 0, all the way to 5/8, and then we're increasing again from 5/8 all the way to infinity. Here, I'm just gonna close that. All the way until infinity. So decreasing slope and then increasing, right? So we don't see a maxima, but we see a minima at that critical point. All right, cool. We're almost done. It was interval notation to indicate where f of x is concave up. So here we got to go to the second derivative now. So yeah, because concave up, concave up looks like a cup, and concave down looks like an upside down cup. So let's do it. I really have no idea what I'm talking about, but it's okay. We have, so what do we have? So f prime of x equals 8 minus 5x. Yeah, I'm just going to write that real quickly. So we have f prime of x equals 8 minus 5 over x. I think that's what we have, right? Yeah. So therefore, f prime of x equals, okay, and this is equal to 8 minus 5 times x to the power of negative 1. So here we have negative 5 times negative x to the power of negative 2. Whoops. Equals 5x to the power of negative 2, and then 5 over x squared. I think that's right. I think. And then okay, I'm sorry. That's the second derivative. Now we have to find when that is 0, so we can find our inflection point, and then we will check whether the sign changes. And we have to check if it's defined on f prime of x. or an f, whatever. Let's see. So yeah, this this never equals 0 because 5 will never equal 0. So then our only hope of finding an inflection point is going to be when this equals 0. And that happens when x equals 0. Is there any other point? No. So, gotcha. So, inflection point 0. So now we have negative infinity to 0, union to infinity. So, checking whether f prime prime of x is positive or not. Let's see. So let's test negative 1. So we get 5 over 1 equals 5. That's positive. And then if we do 1, that's also positive. Oh, interesting. So there is no sign change. So concave up. Oh, well, it's always concave up. So this is going to be negative infinity all the way to infinity. Yeah, because concave up, it's f prime prime of x is always greater than 0. If there are no inflection points, yeah, I think the only inflection point is 0, right? Yes. Oh, hold on. What happens if you plug in 0? We're good. We get like -5 or something. Oh, now we need a sketch. Let's sketch that graph, guys. Let's see. F, right? Want us to sketch F? Let's see. So we know that okay, let's find all the traits. So we have a concave up from negative infinity to infinity. We have a local minima at 5 over 8. It's decreasing from 0 to 5/8, and then all the way to infinity. I'm pretty satisfied with my drawing, so I'm just going to put a 1 over there. What? What happened here? Oh, whoops. Hold on. It's not concave up. I mean, at 0. At 0, it's undefined, so that makes no sense. What? What happened here? There you go. Now that should be correct. Wait, but so 0 is not an inflection point? So is it okay? Hold on. We found that it's undefined for f prime of x. Is it undefined for f prime prime of x? Is it defined for f prime of x? Because if it's not, I think we're in trouble then. So we have what's f prime of x? 8 minus. So so is it none then? We don't have any inflection point. Oh, probably. Oh, that's right. Obviously, we don't have any inflection point because our signs from the left of 0 all the way to the right of 0 don't change. So it makes absolutely no sense. And what? What happened here? Concave up. I mean, we have concave up throughout negative infinity all the way to positive infinity. Oh, what's going on? Concave up, concave up. Let's see. Hold on. So, I mean, we always get. Let's see. We always get something positive. We will always get positive. So we will always get something concave up. So we have negative infinity all the way to. Okay, hold on. What does it read here? That seems correct. That seems correct. Hold on. If we put practice similar, and we put the show solution. Oh, it's not gonna. Oh, yeah, it is. Oh, okay. I forgot. We're only considering from 0 all the way to infinity. So that looks correct. Awesome. Okay. Oh well, that's not bad. Let's go, guys. I mean, I thought I was gonna have a lot of trouble with this problem, but no, it actually was not too grueling. How? Okay, that's a 17-minute video. Okay, we got it in 17 minutes as well. Okay, like on our own. Let's go. All right, guys. Well, we're in question 3. Huh. Now we're gonna have to find horizontal asymptotes and then vertical asymptotes. Oh boy. Okay. Well, let's do this. Let's do this. Oh yeah, that's right. It was from 0. We do not have anything to negative infinity. I was confused about that, but then I just remembered our conditions. Alrighty, let's go. So we have, suppose that f of x, that's a little big, don't you think? Suppose that f of x equals 5x to the power of 6 minus 5x to the power of 5. Find all critical numbers of f. Okay, so we got to find the first derivative. F prime of x equals, just use like the power rule, right? 30x to the power of 5 minus 25x to the power of 4. Beautiful. Now we can factor, right? Yeah. Let's factor. Let's factor. What should we factor? What's a common factor? 5? 5, right? Whoops. Oh, we could have also factored like an x. No. Could we? No. Okay, it's fine. Whatever. So we know that this is equal to 0. So we know that 6x to the power 5 minus 5x to the power 4 equals 0. Well, okay, fine. Let's just go for it. 6x minus 5. Okay, that looks better. Huh. Ouch. So that equal to 0 or undefined. So I don't think we can get anything undefined here because we don't have any fractions. Well, we can probably get 0. So when x is 0, or here we have what, 6/5? Sorry, 5/6. Yeah, because the sixes will cancel. We get 5 minus 5, 0. 0 times something is 0. That's good. So I think we found our critical numbers. And just check before we keep going. That's right. Let's go. Let's go. Yeah, we don't have any conditions, so this looks okay. Beautiful. Beautiful. Now, interval notation now. I'm saying that right. Interval, right? Yeah. How do you pronounce interval? Interval math, how to pronounce. Interval. I can't hear anything. Am I connected to some? Oh, I'm connected to. Interval. We're pronouncing that right. So we're good. We're good. So let's create our intervals. So we have negative infinity, all the way to 0. Union 0 all the way to 5/6. Union. Well, that looks like a very weird union. Union, comma, infinity, and beyond. Let's see. Only pay for what you need. Sorry. So yeah, now we just gotta see when f of x is increasing, right? That means when f prime of x is greater than 0. So what's f prime of x? We just found out, right? What in the world am I doing? So we have, come on, let's go. So we have f prime of x. So if we plugged in -1, we would have gotten negative. So then we have negative 6 minus 5. Wait, negative 6 minus 5. And that equals negative 11. 11? I think I got that right. I could have gotten all of that wrong, though. So we got oh my gosh. Yep, we did get that wrong. Sorry, it's fine. So if we have, okay, negative 1 to the power of 4 times 6, that's negative 1 minus 5, right? Yeah. So this is positive, negative 6 minus 5, negative 11. So, okay. So here we have negative 11. So that's negative. Beautiful. Now something in between 5 to 6. All right. So yeah, we're obviously we're not going to plug in anything because it's going to be a little too much algebra. Or am I not? That's fine. So we have 5 6 to the power of 4 times, it's times, right? We got times, yeah. Times oh, what am I doing? We're going to get 0. Something in between. We get a positive times positive we're probably going to get negative there. Oh, we're going to get negative there. So this is going to be f prime of x is less than 0. And how about above 5 6? So we know that this is going to be positive over here, right? Yeah, that's positive. And then here we're going to get positive. So here we know that f prime of x is greater than 0. So it looks like the only time it is increasing is going to be from 5 6 all the way to infinity. Is that right? Okay, we got that right. Let's go. Yeah, decreasing. Yeah, well, it's only going to be from negative infinity to 0, union 0 all the way to 5 6. Cool, and that's also correct, right? Awesome. Okay. Awesome. And let's see. So maxima, positive, negative. Looks like here we have negative, 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 and then positive now. So we have no maxima. That's none. This is going to be, well, at the point 5 6, because that is where we switch from negative derivative to positive derivative. Concave up, time to calculate the second derivative, because why not? No, I was kidding. I mean, because we have to, right? There we go. Hold on. Where's our derivative? Oh, where's our derivative? What in the world? Oh, there it is. So we have f prime of x equals x to the fourth times 6x minus 5. That's what we have, right? No, because we need the second derivative. So we have f prime prime of x equals 4x to the power of 3. I see. All right, product rule time. So we have x to the power of 4 times 6 plus 4x thirds times 6x minus 5, right? I didn't do anything stupid right here, right? 4 plus, should we expand? Sure, let's go ahead. Shouldn't hurt. 24x to the power of 4 minus, and that's the 5, right? So we get 20x to the power of 3. I see. Oh, okay, yeah. And we can simplify even further. Cool. And we can simplify even further. Or we can make it look cooler. Make it look simpler. 10, 2. There we go. Yeah. Makes sense. We need that equal to 0 because we need to find our inflection point. So we have 3x to the power of 4 minus 2x to the power of 3. No undefined points, but let's see what equals to 0. Well, we have, well, yeah, x equals 0, right? That's all we have. And we need something like, is there anything else? Let's see. If we have like, I have a feeling that we can get 0 when x is not 0, but like through a weird fraction. If we have like 2/3. Yeah, no, that's gonna be a little tough. No, okay, it's fine. Well, here it's gonna be concave up. When? Well, let's see. Let's create our intervals. So we have negative infinity all the way to 0, union 0 all the way to infinity. 3 minus. So we have 3 minus 2 times. Okay, choosing -1, we get 3 times -1 to the power 4, which is 3 times 1, 3. 3 plus 2 equals positive than 0. -1 to the power of 3 is -1. -2 times -1 is 2. 3 plus 2 is greater than 0. So therefore here we have f prime of x is positive. Now we gotta guarantee a sign change though. So let's see. So we have 1. So we have 3 minus 2, right? Simple. Yeah. Equals, that's still greater than 0. So no sign change. So concave up forever. And inflection point, well, no, we don't have any inflection point. Okay, hold on. Wait. I'm sorry. Yeah, here f prime of x is also a greater than 0. But it's asking me when it's concave down, but it does not give me the choice to enter no or like none or something. So must have gotten something wrong here. Let's see. So if I plug in -1, hold on. Okay, hold on. Right now, are we gonna go? So yeah, this concave up is wrong. Um, so did we miss an inflection point, or did we miss like a point where the second derivative equals to 0? So we're gonna play like that. Okay. So we have x equals 0, that this equals to 0. And we also have, let's see, so 3 minus 2. Uh oh, well. So how did he do it? Oh, hold on. Wait. So if we just do like, whoops, forgot we could have simplified it that way. All right, cool. So here, yeah, when x equals 0, obviously. And then when x equals 3/2, right? Whoops, nope, 2/3. We also got, there we go. Okay, so we can, in fact, we can like get rid of all of that here. We'll just take everything out. We don't want to spend a lot of storage. Two-thirds. So we have -infinity to 0, 0 to 2/3, 2/3 to infinity. So f prime prime of x, what do you equal? -1. Here we have negative, negative, positive. So we have -3. Oh, sorry. We also have negative here. -3 minus 2. That's going to be negative. Negative. So this is positive. Here, what do we have? So if we choose anything in between there, so this is going to be less than 0, negative. That's positive. So this is negative, less than 0. And here we're going to have something positive. So concave up is going to be from negative infinity to 0, union 2/3 to infinity. And concave down, well, it's going to be from 0 all the way to 2/3. And this is correct? Perfect, yeah. So the inflection points, easy. So now here it looks like the sign changes from positive to negative, then from negative to positive. So yeah, so we have 0 and 2/3. Those are horizontal. Okay, horizontal asymptotes. Gotcha. Where's our second derivative? Right here. How do we check horizontal asymptote again? As so as x tends to infinity, y tends to infinity, right? Yeah. And then as y tends to infinity, yeah, none, because I don't think we have any like undefined point. And sketching our graph, let's see. So from negative infinity, concave down, so we have something like that. And then here looks like we have concave up, then concave down again. All right, I'm satisfied. Oh, so y is not infinity. So this is infinity times infinity minus 2. Yeah, bro. I mean, I don't know. I mean, that's not infinity. Oh, okay. So there are also none in here then, because it tends. I'll have to review that. Oh wow, that's 3 questions. I'm tired. You don't know why you're here? Well, dude, we're just glad you are. Thank you for joining us here, man. It's good to have you here. Oh, okay. Okay, hold on. So we have. Oh, it looks like the questions just got a little easier. We got 2 videos. Then we have that. Okay, not bad. Cool. Let's do this. All right. So that's a lot. Let's try to. Hold on. All right, cool. All right, so we got to. Oh, okay. Sorry. How long do we go? We only go 38 minutes. Okay. And our stamina is already running out. I think I'll take a shower midstream probably. F of x equals 1 minus 6x squared. Where x is in between -4 and -1. Gotcha. In 1. So the absolute maximum value is. How do you find an absolute maximum value? Check the endpoints and the critical point, I think. Wow, I gotta review those videos. Let's see. So, yeah. So we gotta find the derivative. -12x. Cool. And then we gotta see when this is equal to 0, and that happens when x is equal to 0. Cool. So what does that mean? Okay, in fact, here, I'll just put x is equal to 0 right there to make it neater. And okay, and this is our interval. So we have -4 and 1. In fact, I'll just write it right here. Is this a closed or open interval? No, this is a closed interval. -4 to 1. Gotcha. We could have just checked all the integers, but it's fine. No, we won't do that. Let's see, -4 to 1. What does that mean? Well, so first, let's check. So f of x, evaluate, 1 minus, and then we get 0. Bro. So f of 0 equals 1 minus 0, which equals 1. Then we have f of -4, and that equals 1 minus 6 times -4 squared. That equals 1 minus 6 times 16. That equals, let's see, 160. 1 minus 96. Yeah, that's pretty low. And this equals -95. So yeah, fat chance. And then we finally have f of 1. And that equals 1 minus 6 times 1 squared, which equals 1 minus 6, -5. Absolute value, 0. Oh, hold on. No. Sorry, that's not true. It's 1. This occurs at x equals 0. There we go. Beautiful. That's so hot. Let's go. And then our absolute minimum is going to be -95, which occurs at -4. Let's go. Let's go. Let's go. Let's go, guys. You guys see that? That was not bad, actually. Let's keep going. In fact, I think I'll have to delay that shower. Now, we got to consider the function f of x equals 2x cubed plus 12x squared minus 126x plus 3. Between where x is in between -7 and 4. So creating the interval, it's an open interval because the endpoints are included. We have -7 all the way to 4. What a nice interval. I mean, wow, that's so neat. Let's go. Okay, hold on. So -7 all the way to 4. This function has an absolute minimum value equal to absolute minimum value. Okay, cool. So they're asking about the result by plugging in the x. Whatever. I'm going to shut up. So f prime of x, oh, easy. Okay. We're already given the simplified version. 6x squared plus 24x minus 126. Cool. So let's evaluate. What do we evaluate? Oh, I'm sorry. Well, let's make this equal to 0 for a second. So let's see. When does this all equal to 0? So now it's a good time to simplify. So 6, we have x squared plus 4x minus, I don't know, 21? I think 21, right? Yeah. So x squared, yeah, who cares about that? 6, right? All right, we have that. We know that this equals to 0. And I don't know why that extra parentheses right there. So to solve for x, we could use the binomial quadratic formula, or we could find two values that multiply to 4, or sorry, that add to 4 or multiply to -21. And that's going to be, let's see, 3 and 7. I think 3 -7, x plus 3 times x minus 7, x squared minus 7x plus 3x. Oh, hold on. X minus 3, x plus 7. So x squared, 7x minus 3x, that's 4x. And then -3 times 21, sorry, times 7, negative, perfect, beautiful. So the x values that make this equal to 0, that make this equal to 0 is going to be 3 and negative 7. Beautiful. So we have two critical values. Oh, and we got to see if this is valid. Yeah, no, it's valid. Polynomial function, the domain is all real numbers. So we got to check also negative 7. Yeah, so negative 7. Oh, that all overlaps. So negative 7, 3, and 4. So, and we got to do this in f prime of x. Got you. No, hold on. Where do we check? We check these values to see which gives. Hold on. Oh, sorry. We check it in f, not in f prime of x. So let's do this. This might take a little more time, but it's okay. So we have this cubed plus 12 negative 7 to the power of 3. Whoops, to the power of 2 minus 126 times negative 7. That might take some time. Should we open up Desmos? So 2 times negative 7 to the 2 times negative 7 to the power of 3 plus 12 times negative 7 to the power of 2 minus 126 to the power of negative 7. 784. It's beautiful. Whoops. Hold on. Oh boy. Oh wait, and we still have to add that last number, right? What's our number? 3 plus 3. No. So, and then let's check with 3. Okay. And then we will check with 4. Cool. So we have 787. What do we get? Yeah. And, oh, sorry, and this is minimum. So this is, okay, negative 213, 787. Yeah. All right, I think that's correct. Cool. In fact, I was nearly convinced that I got an algebra error, but I'm pretty surprised that we did not. We're actually cooking. It's tough, I know. Thanks, man. Thank you, guys. Whew, 4 people in here. I thank y'all for coming. How are you guys? Tell me more about yourself. How many questions left? I think we have 6 questions left. I know I still have a lot to do. Yeah. What math are you guys doing? Are you guys like in high school, middle school, or like in college? How long does this take in total? Let's see. This might take me like maybe an hour and a half, probably. High school math. Okay, cool. Yeah, I'm pretty sure we're doing like a similar level, probably. Should we take a quick nap? I think I'll go take a quick nap. No, just kidding. Yeah, no, I'm not gonna do that because we still got 6 questions left. Okay. All right, guys. Well, let's continue. Because why not? Thank you. Thank you a lot, man. Yeah, it means a lot. Will do. I'll lock in. Let's see. Let's do it over here. All right, cool. That's good. So we need to find the okay. It's a little dark in here. I'm just gonna turn it up a little bit. There you go. So we need to find the absolute maximum and absolute minimum values of the function f of x on each of the indicated intervals. Oh, gotcha. So these are all local maximum. Why is it saying an absolute maximum? I'm confused. Let's see. I mean, what I remember is that absolute maximums are like the maximum value, um, the maximum x throughout the entire domain. Weird. It's fine. So we have f of x equals x minus 2 times x minus 5 cubed plus 10. Okay, so what do we do? So first, I think we should find the critical points. Cool. Okay, so let's do the product rule. So first, this times 1, right? Yeah, 1. So plus, and the derivative of x minus 2 is 1, so doesn't matter. Here we only have this. Okay, and then we have this plus, oh yeah, no, not plus anything. So we only have this. Should we expand or oh yeah, I think we should expand. Okay, sorry, here. So this is equal to x minus 2, 3x minus 15 plus, yeah, I'm not going to expand that out. Cool. And I think we should expand this top part. So we should have 3x squared minus 15x minus 6x plus 30 plus x minus 5 cubed. Looking pretty. And now we have 3x squared minus 21x plus 30 plus x minus 5. Cool. Or hold on, should we have kept those binomials? Am I expanding what I'm not supposed to do? All right. So from here, what can we see? I mean, yeah, from like all okay, that's incredibly ugly. I don't know why I did that. So we know that, let's see, x equals 2, 5, and 5, like a double root over there. We'll make all of this equal to 0. Am I doing the right steps? Hold on. How do you simplify this? Okay, you're not going to. Okay. Because I was gonna factor again, but yeah, hold on. If I factor, if I do, okay, I think I'm going in circles, but I'll get this, 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 plus. So I think I'll get that. So what happens if I do? Let's see. So that adds to -7 and multiplies to 10. How about, and then multiply 5 and 2? Oh yeah, right. -5 and -2. Beautiful. Negative, positive when multiplied, and negative when added. And this is plus x minus 5 cubed. Was this what we got before? Yeah, whatever. Okay. All right, dude. Yeah. We're just so all of this useless. It's fine. We 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 did some algebra. It's okay. It's okay. Let's see. So now what? Make it equal to 0. Let's go. So this equals to 0. So we have x equals 5, 2, and 5. So just 2 and 5. 2 and 5. No undefined. So these are our critical points. So let's create our intervals. But they're giving us the interval right here. So what's going on? Fine. Within 1 and 4. Wait, so was this utterly useless or what? Okay, whatever. So we have f prime of x equals this. So on the interval, so 1 or 4, let's choose, I don't know, 2. We get, so we have f prime of 2. This is going to equal 3 times, yeah, we chose 2, right? 2. So 2 minus 5, we get negative 3. Here we get 0. Oh, that sucks. Let's choose one that's not one of these critical values we got here. Let's put this in a box or something, because why not? Let's do 1, because this is a closed interval, so the endpoints are included. So we get negative 4, then we get negative 1, then we get negative 4 cubed, bunch of negatives right there. So we get 12 minus 64? That's clearly negative. Oh, but we need to solve for that. So this is going to be negative, negative what? Negative 52? Negative 52, I think. Oh, I'm sorry. No, we're finding a maximum. So we do the critical points and then we do the intervals. Oh, but so 5, we exclude that because it's not within our interval. So, okay. Yeah, I'm not going to put anything there yet. So cool. Now if we do f prime of 4, we have 3 times 4 minus 5. Fine. We have 4. What? 4 minus 5. That's negative 1. 4 minus 2. Oh, we have positive now. Plus 4 cubed. So here we have negative 6 plus 64 equals 58. Gotcha. And now f prime of 2. F prime of 2, that's going to equal 3 times. So we, hold on, x minus 5 and then x minus 2. So 2x, that's equal to 0, I think. Oh, no, it's not. It's equal to x, hold on, that's equal to negative 3. Negative 3 cubed, that's negative 27. It's fine. It's not an extrema. So our absolute minimum is going to be negative 52. Then here we're going to get 58, I think. Great. 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 Okay. Hold on. Let's keep going. What happened here? What's on my mind today? I don't know. Oh, so I can use this Copilot now. That's kind of cool. Whatever. Yeah, no, I got nothing. Okay, hold on. Here, I'm just gonna use Desmos. So we have f of x equals 2x minus 2, x minus 5 cubed plus 10. I'm just gonna. So f prime of x equals 2 x minus 2 3, x minus 5. Oh, that's what we forgot. That's what we forgot. The 2. That's what we forgot. It's fine. I'll just keep doing it here. Here's much faster. Plus the derivative of x minus 2, which is 1. And then we have x minus 5 to the power of 3. Cool. Gotcha. I think we did that correctly. Yeah. Okay. Hold on. F prime of x. Why isn't this equal to that? Weird. Okay. And now we gotta. All right. So now f prime of 1. Then we have f prime of 4. Gotcha. And then f prime of 2. So it looks like our absolute maxima is going to be 5. Oh. Hold on. How do you do this? Oh yeah, the closed interval method. Oh, good luck on your math exam, man. Yeah, we gotta do F. Gotcha. So I think, hold on. So, hold on. Wait, no. Now we gotta do you do F of 2 then? Yes, F of 2. 10. So this is 10. Oh, that's not 10? Oh, okay. Well, we need to find what. Oh. I mean, it's not 8, right? Yeah, it's not 8. Oh, wow. I'm tired. We go 1 hour on this. Gotcha. Okay. Let's see. Think. Um. Hmm. Um. So okay, here. I think this is taking long. I want to see what I am missing. How? Okay, I don't know. How would you approach this problem. Yeah. Oh, let's see. So find critical points by computing f prime of x and solving f prime of x equals 0. All right, here. I'll do that. So we have f of x equals x minus 2, x minus 5 to the power of 3 plus 10. So the product rule is going to be gotcha. Perfect. Oh, and this is let's see. So now when this equals 0. So wait, by computing f prime of x and solving. List candidate points. Yeah, so we have that. Differentiate by product rule. Oh yeah, right. We can factor x minus 5 to the power of 2 to get x minus 2. Hold on. X minus 2, 3 plus x minus 5. Right. And then here we do. Okay, so you just simplify there. So we get times 3x minus 6 plus x minus 5. And by simplifying, times to the power of 2, right? We have 4x minus 11. Perfect. Yeah, what you got. And then solving for f prime of x equals 0. Well, let's see. X is going to equal 5 or 11 fourths. A double root. Yeah. Oh, awesome. Yeah, 11 fourth. Sorry, that's what I meant. Right. And that's actually what I wrote. These are the only critical points. Perfect. And then, so we have, so evaluate at 1, at 4, at 5, and then at 11 over 4. Evaluate f. So this will probably take long, so I'll just use the calculator. So we have f of x equals x minus 2, x minus 5 to the power of 3, I think, plus 10. Right. And then here we have, so we have f of 1, f of 4, f of 5, and then f of 11 over 4. Here, I'm just going to remove all of this. There you go. So yeah, so f of 1, that's going to be the 74 we got. And our minimum is going to be, what's this in fraction form? 373 over 256. Okay. And then we got to evaluate this also in the interval from 1 over 8, sorry, 1 to 8, and then 4 to 9. Gotcha. Hold on. So, if we press the mid answer, that's correct. Let's go. Okay. We're back on the game. We're back on the game. Now, so, wait, hold on. So, bro, literally easy. 172. So that's 172. In this, I think this stays the same, right? Let's see. So I think that might be the minimum. Okay, no, I'm not going to do that. Sorry. And then we have f of 9, 458. So that's probably going to, so 458, that's the biggest we have seen. And then we have 8. That's the lowest we can go. 4, 8, and then 458. And how about 5? F of 5, what did we get? Yeah, 10. So that's neither maximum or minimum. And 11 over 4, that's going to be like a 3. So it's not going to fit. Let's go. We're actually moving again. We have 5 problems left. This is taking some time. Wow. What if I watch myself on YouTube, like literally? Just like watch yourself on YouTube. That's so funny. I literally see myself. I look like that? Okay. So what am I doing over here? Gotcha. I see. Okay. Gotcha. Okay. All right. Enough break time. We're back because we still have 5 problems to finish before the end of the stream. And we have 2 people watching. Let's go. Welcome back, guys. Oh, well, I mean, I just solved this. So what happened here? Yeah, I mean, easy, right? Easy. So let's go back here. Here, I'm just gonna close the door because yeah, I'm last screen right now. All right, man. Love you, bro. Cool. That was my brother. So I'm tired though. I mean, I'm tired. Let's see. What else we have? We have that. Oh, well, we got to finish all of that. So minimum. Wait, how do you find an absolute minimum again? Wait, so how did I find this? Oh, right. That's what we did. Okay. All right. Let's continue. So we have negative x over 3x squared plus 1. In fact, here, I'm just going to put a line over here. There we go. So we have negative x. In fact, I'm just going to put this one row higher. So we have negative x over 3x squared plus 1. On the interval, 0 all the way to 2. So we have a closed interval from 0 to 2. I see. For each of the following, enter D and E if a value does not exist. So the function has an absolute minimum value equal to blah, which is attained at x equals blah. And then a maximum value. Gotcha. I wonder why they do minimum and then a maximum. Weird. It's fine. Doesn't matter though. Irrelevant. So first what we got to do is find f prime of x, the derivative. And we do quotient rule. Why? Because we have a function at the top and the function at the bottom. So First, we do derivative of numerator, and that's going to be -1, times plain old denominator minus plain old numerator times derivative of the denominator. 6x, that's it. Over, all of that over, g of x squared. So that's going to be 3x squared plus 1, all of that squared. And now we need to find the values of x that make all of this equal to 0. Sorry, what did I say? We need to find the value of x, make all this equal to 0. What does that mean? Why? Because those are the critical points. That's right, baby. So it looks like we can simplify, I think. Let's simplify because, like, why not? So here we have negative 3x squared minus 1 minus negative 6x squared all over 3x squared plus 1 all that squared. This is equal to negative 3x squared minus 1 plus 6x, all of that over 3x squared plus 1, all of that squared. This is equal to, oh, well, I mean, we have a polynomial, so I don't know what to do. Are we sure we did this right? I mean, the derivative of negative x is -1. It's basically just negative all of that. Okay, I mean, I don't think I can simplify anymore. Well, in fact, what if I expand the denominator? What happens if I do that? Well, we get 3, sorry, not 3. We get 9x to the power 4. Oh my gosh, just let me train of thought, dude. What am I doing? Yeah, I'm expanding 3x squared plus 1 all of that squared. So we have 9x squared plus 3x squared plus 3x squared plus 1. And then, yeah, so we have negative 3x squared plus 6x minus 1 all in the numerator, all over. And then by simplifying in the denominator, we have 9x to the power 4 plus 6x squared plus 1. I might have gotten all of this wrong. I'm sorry if I did. How on earth? Oh, sorry, no. Oh, we're good. Should we? Oh no, I actually have no idea why I would simplify that. It's fine. Let's see. So, let's see. What values of x make this equal to 0? Well, I don't know. I mean, I want to. How do you simplify that function? Oh, whoops. Really dumb mistake. It's quadratic, not linear. So here we have negative 3x squared plus 6x squared minus 1 all over 3x squared plus 1. All right, cool. Let's just go from there. So this equals to 3x squared minus 1 over 3x squared plus 1 squared. Conjugate time or no? Let's see. Oh, I see. Okay, 1 over square root of x. By squaring that, we get 1 over x. 6 times 1 over x is 1. 1 minus 1 is 0. Gotcha. Okay, beautiful. So we can apply that same logic by saying that x can equal 1 over square root of, I don't know, 3. because then by squaring that, we get 0 in the numerator. Oh, yeah. And then we have negative 1 over square root of 3. And that's 0 in the denominator as well. Beautiful. Love you all. Wait, what? Hold on. Oh, no. Wait, what? Why did you get a negative there? Okay, that's fine. But let's see. So we have x equals 1 over square root of 3, comma, negative 1 over square root of 3. Oh, yeah. Negative 1 over square root of 3 is not in the interval, so we can just cross that out. They can leave, like, get out of here, you know? And then the function has an absolute minimum value equal to, all right, so we have 3 candidates. We need to check f of 0, f of 1 over square root of 3, and then f of 2. And we're going to check this by doing Desmos. So we're just going to get all this off. Bye. I'll see you later. So we have negative x over 3x squared plus 1, I think, right? Yeah. Or f of x. There you go. So what's f of 0? F of 1 over square root of 3. And then f of 2. So minimum value. Looks like this is it. Let's put that in there. At x equals 1 over square root of 3. And then the maximum value is is 0. And that's attained at x equals 0. Cool. Let's go. Oh, wow. I'm getting tired, guys. We go almost an hour and a half. But no, we can do this. We have how many? We have 4 problems left. Perfect. Let's continue. So we have f of x equals x cubed plus 12x squared minus 27x plus 3. We need to find the absolute maximum and absolute minimum values of the function over each of the indicated intervals. Okay. So let's see what we have. So in the interval from negative 10 to 0, we need to find the maximum and minimum absolute. You winner. Okay. So we're literally just. So we have f prime of x. Let's find the derivative. We get 3x squared plus 24x minus 27. Beautiful. And we need to find the values of x that make this equal to 0. So we can, factor 3. So we get x squared plus 8x minus 9. 9. There you go. So we can get rid of that 3. We only have x squared plus 8x minus 9 equals 0. Gotcha. Binomial? 2 binomials? I don't know. Let's see. So values that add to 8 and multiply to negative 9. How about that's a tough one, actually. Oh, well, 1 and 9, right? I mean, negative 1 and 9. Whoops. Negative 1, and then x plus 9. Yeah, that'll multiply to negative 9, and that'll add to 8. Perfect. Perfect. So x equals 1, and negative 9 will be our candidates. So yeah, we won't consider that 1 because that 1 is outside our interval. So now let's write our function in Desmos. Bro, no thank you. There we go. So we have f of x equals x cubed plus 12x squared minus 27x plus 3. So f of negative 10. What? Oh, whoops. Get rid of these. Bye-bye. Negative 10 and 0. So f of 0, f of 1, f of negative 9. So we won't consider that 1. So bye-bye. Let's see. So absolute maximum, 473. No, it's 489. Then our absolute minimum is going to be 3. And I won't even bother to check. Gotcha. Cool. Now, f of negative 7. And then we have f of 2. And we can also check f of 1. Right, So maximum, 437. Minimum, negative 11. Beautiful. Now, here we will check f of negative 10 again, I think. F of, f of 2. Check negative 9 and 1. F of negative 9, f of 1. Beautiful. So 489 in the minimum, negative 11. Guys, look how fast we're going. We got all of this right on our first try. Let's go. We have 3 questions left. Let's go. Let's go, guys. Oh, 3 questions left. We have 3 questions left, guys. Hold on. So we have that. Doesn't look too hard. We have, all right, that looks kind of tough. What? True and false quiz. Gotcha. Okay. Actually does not look too intimidating. Nobody's watching though, so that kind of sucks. But it's fine. Oh, 2 people just joined. Oh, let's go. Welcome, guys. Thank you for joining. Because we're cooking, actually. So we have f of x equals 4x natural logarithm of x minus 8x. 4x greater than 0. Find the x coordinate. Absolute minimum for the function. Let's see. We x coordinate of absolute minimum. Absolute minimum. Okay. So let's find the derivative. F prime of x equals. So it looks like we're going to have to do a product rule. So 4x times 1 over x. Wait, yeah, ln of x, right. Plus 4 times natural logarithm of x minus 8. So simplifying, we get 4 plus 4 natural logarithm of x minus 8. Finally, I think we get something like 4 natural logarithm of x minus 4. Cool. And this should be equal to 0, so we can factor 4 times natural logarithm of x minus 1 equal to 0. So we, in reality, have natural logarithm of x minus 1. Gotcha. So x, so what value of x makes natural logarithm of x minus 1 equal to 0? Oh, so e to the power of 0 equals 1. 1 minus 1 is 0. Perfect. So x equals 0. Anything else? I don't think so. I think 0 is going to be our thing. Oh, but x greater than 0? Oh, well, that sucks. What do we try then? What do we do? Hold on. What did we do for? Was it this one? It's fine. So how did we do this one? Sorry, how should we do this one? Or you're not going to tell us? Oh, wait. He did. So, yeah, I think I got 4 ln of x minus 4. Yeah, a different problem. So, f prime of x equals 0 yields x equals... Hold on. Wait, what? So you don't simplify? That's so funny. I actually thought we were All right, so it's fine. So I'm just gonna cross that out. Cross that out as well. Um, so you said x equals e to the power 5/4. So e base e to the power 5/4 is 5/4. 4 times 5/4 is 5. Brilliant. So here, that implies that x must equal, so e, so we need something like 4. Okay, what do we need? We need 4 times something to equal 4. So 1. So all of this, so ln of x needs to equal 1. And that equals when x equals 0. Or 4 over 4. Wait, I'm sorry, what? I'm confused. We need 4 times whatever to equal 4. So ln of x should equal 1. Oh, that's not 0. That's not 0. ln of x. Hold on. Okay, hold on. So f of x needs to equal 1. So, well, what if I just do e to the power of 1? Or, wait, I'm sorry. So e, so log base e raised, wait, what? Hold on, where are we? There you go. So that's e of e to the power 5/4. So that's e raised to what gives e to the power 5/4. So here I need to get, so there you had to get 5/4. Here I need to get 4/4. What? Oh, well, 1, right? I mean, so e raised to what gives e to the power of 1. But I don't want e to the power of 1, though. No, but I won't get e to the power of 1. I'll just get 1. So e to the power of, hold on. So, sorry, I'm just going to go back here. So, why do we have to apply L'Hopital's? Why is it, what does it say? Hospital's rule. It's L'Hopital's rule. All right. I'll have to check later. It's fine. However, so e raised to what power gives e to the power of 1? And that's 1. So we have e to the power of 1, or 4 over 4, or 1, or just e. Huh. Oh, hold on. Wait, an absolute minimum. Wait, no, not yet. We have to. What do we? Uh. So okay, I'm confused. I'm like, oh yeah, f. So we have to do f of e. That's 38 something. Then what's this for? Wait, but why do we have to apply a limit? My connection is unstable. What is my laptop? All right, let's apply L'Hopital's rule then. So we have the limit of the function Oops, yes. Times what? Right. Equal 0. And then you do the same thing, but from the left. Gotcha. That's infinity, right? Well, okay. E. Well, okay. We have 2 problems left, guys. 2 problems left. Can we do it? Can we finish these last 2 problems? Because it looks like we have like 20 minutes left. We actually did pretty good over here. Kind of proud of myself. Too bad we have to delete it all. Gotcha. Okay. We have 2 problems left. Can we do it? I think so, right? Yeah. And stream? Not yet. Why did my forehead look like that? Weird. Gotcha. It's a nice room though. Cool. Well, so hold on. So now what do we have? So we have now f of x equals 3 plus 6 ln of x over x for x greater than 0. Now absolute maximum. So we just found the absolute minimum. Now it's time to find the absolute maximum. And do we still have to use L'Hopital's rule? Yes, we do. Well, it's fine. So let's find the derivative. So 6 over x, right? The derivative of 6 ln of x is 6 times 1 over x. All right. Times x plus, minus, my bad. Minus that times 1. So nothing. Get out of here, Sherlock. Now, derivative of x squared over x squared. Yes. Simplifying, we get 6 minus 3 plus 6 ln of x over x squared. And finally, we get something like 3 plus 6 ln of x over x squared. That's so funny. We literally got like the exact same thing, except rather than an x, we got an x squared. Oh, now what? Now we got to find what equals to 0. How we can find what equals to 0? Yeah, I'm just going to look at how to do it. You'll be in my heart. Okay, hold on, wait. So solving. Oh, yeah, well, literally the same thing, right? So what makes this equal to 3? Oh, no, we needed that to equal 4. Gotcha. So here we need this to equal 3. This equal to 3. So that means 3 over 6. We need 6 ln of x need to equal 3 over 6. So no. Sorry. Ln of x needs to equal 3 over 6. There we go. So so if we have e to the power of 3 over 6, so this is going to be e raised to what power gives e to 3 6 or 1/2. Love it. So e to the power of 1/2. Yeah, right? E to the power of 1/2. And yeah, after just using L'Hopital's rule, we just find that the left and the right are different. Yeah, no, I'll have to repeat that. All right, now we just have the last question now, guys. Answer the following true-false quiz. All right, let's do this. I think we have a solid understanding of everything, so we should do this well. If f of x and g of x are increasing on an interval I, then f of x times g of x. Oh, welcome back, man. Oh yeah, the first commenter of the stream. You're doing stats homework. Gotcha. Okay. Are you also in high school as well? Because I heard that stats in high school is kind of tough, a little bit. Well, cool, man. Tell me how it goes. Facts. Freshman in college. Oh, really? Okay. Well, you're taking stats early then. I think many kids usually just take it around like their junior year, probably. Well, good for you, man. Do you think it's hard? Do you think stats in high school? I'm sorry, in college. I'm sorry. I thought you said in high school for a second. No, in college. Oh, well, that must be like 2 times tougher then. What major are you majoring in? Sorry, man, I'm just losing my mind right now. I don't know why I assumed you're in high school. Okay. A pre-med. Wow. That's impressive. I didn't know you had to do stats for pre-med though. Interesting. Well, yeah, probably one of those non-core classes, right? Probably one of those, yeah. Do you find it hard? Do you have to use like a lot of math in that one, or like calculus or something? Hmm. I wonder if stats is like, oh, general education. Oh, gotcha. Okay. Yeah, what do you see in stats? Statistic. No, no. I mean, it's not just statistics. It's like stats. Stats. Uh, college course. Oh, what do you see there? All right. So I guess it's more like analyzing data. ANOVA. Okay. I'm not sure what that is. ANOVA definition, I think. Analysis of variance. Oh, really cool. It's a method used to compare the means of three or more groups to determine if there are significant differences among them. Interesting. Okay. Partitions the total variability in a data set into two components. Between group variability, differences due to the effect of the independent variable or treatment. Differences due to the effect, okay? And then within a group variability, random variation or error within each group. Random variation or error. Gotcha. Okay. I'm not sure what all of this means. I can see what it does, but I don't think I understand everything completely. But that's pretty cool, man. Yeah. Good luck on pre med. Must be a bunch of reading. I mean, I don't think I'd survive it in pre med. Oh, gotcha. Okay. Cool. Oh, that's awesome, man. Yeah. Yeah, I had to read this a Campbell biology last semester as well for biology. It was I mean I loved it, but it was a bunch of reading. Oh, Hammond, good luck. Yeah, good luck on your future years. I hope you also enjoy them as well. Let's see. Hmm. Really? Oh, cool. Okay. From Campbell. Okay, that's awesome, man. So, if f of x and g of x are increasing on an interval I, then f of x times g of x is increasing. I assume true, right? I mean, okay. Um, continuous functions are differentiable. Continuous functions are differentiable. Uh, oh well, I mean, yeah, I think so as well, right? I mean, I might be getting this all of this wrong, but I think I'm right. If f prime of c equals 0, then f has either a local maximum or a local minimum at c. Let's see. I mean, we know we found a critical point, but no. Sorry, that's not true. F prime of c. No, false. We have to check whether the sign has changed. Thank you. No, I'll just finish this quickly, and then we can go back to chatting if you want. Yeah. No. Thank you. Yeah, I'll just take a couple minutes probably. F of x plus g of x prime equals f of x f prime of x. Yeah, true. Per differentiation rules, right? Yeah. If f of x equals e squared, then f prime of x equals 2e. That's not true. I think it only equals e squared. If f prime of c equals 0 and f prime prime of c is greater than 0, then f of c has a local maximum at c. Hold on. So if f prime prime of c equals 0, then we know that the function is concave up. Concave up, and that means it has a local maximum. Yes, true. Mm-hmm. A continuous function on a closed interval AB attains a maximum and a minimum value at AB. Attains a maximum. Like in AB. Oh, yeah. Well, within the interval. I suppose so. I think I'm confident between these 5 right here, but how many attempts do we have? Hold on. We'll show how to do it. Oh, that's right. That's the extreme value theorem. Oh, hold on. Wait. Yeah. A continuous function on a closed interval AB attains a maximum and right, true. F prime of C. I think this is true. This is not true. That's true. Yeah, maybe hold on. So 2. So this is so not all continuous functions are differentiable. Gotcha. Okay. What else do we have? If f prime of c equals 0, then f has a local. No, right? False. It can be an inflection point. Oh, that's right. It can be increasing and then increasing. If f prime of c equals 0, that's the second derivative test. Oh, that's right. Right. And then increasing. Oh, so that's probably the one I got wrong. Differentiable functions are continuous. Oh, so differentiable functions are continuous, but not all continuous functions are differentiable. Gotcha. So this is false. This is good. Cool. Awesome. All right. Hold on. I'm just going to move this back here. We can close this. Great. We finished our homework. That took forever. How long did it take? That took 1 hour and 53 minutes. Gotcha. 100 out of 100. Let's go. Yeah, I think I understood overall everything, but I think I still need to practice a lot. Let's see. Then we have this optimization problems, and then we have integration. Woo, okay. Well, everyone, thank you for watching. Yeah, I don't know what else to say. I thank you guys for joining my live stream. It was a lot of fun. Doing calculus with you guys. I love your guys' company. Thank you for joining. I think I'll see y'all next time, right? Yeah. I'll see y'all in the next live stream. Okay. Well, I'll see you all. I think I'm getting pretty hungry now, so I think I'll eat something. Okay. Have a good day, everybody.